Hi everyone, today I was supposed to explain as a LeetCode problem, but the LeetCode was in the middle of maintenance mode, so I couldn't access it. So I changed my plan. I'll explain one of the most well-known sorting algorithm, bubble sort. So bubble sort is very simple and easy to understand. First of all, we take two numbers like index 0 and index 1, and compare two numbers. If the first number is greater than second number, we swap the number. So let's begin. So first number is 7 and the second number is 4 and the 7 is greater than 4. In that case, we swap the number. So index 0 is 4 and the index 1 is 7. And then next compare index 1 and the index 2. And again, and the first number is greater than second number. In that case, we swap the numbers. So now 2 and index 2 is 7. And then compare index 2 and 3. And the first number is actually less than second number. In that case, we don't swap the numbers. And then next, compare index 3 and the index 4. And the index 3 first number is greater than second number. In that case, we swap the number. So index 3 is 8, index 4 is 9. So this is the first iteration. Okay, in the second iteration, actually we do the same things, and we take two numbers and compare them, and then if the first number is greater than second number, we swap the numbers. So let's begin. And now we find the 4 and the 2, and the 4 is greater than 2. In the case, we swap the number 2 and 4. And then next compare 4 and 7, and 4 is less than 7. In that case, we swap the numbers. And then next compare 7 and 8. 7 is less than 8. In that case, we don't do anything. And then next compare 8 and 9. And 8 is less than 9, so we don't swap the numbers. And the second iteration ends. At the end of iteration 2, we know that input array is already sorted, but the program doesn't know whether input array is already sorted or not. So even if input array is already sorted, the program continue to try to sort input array. So in this case, program iterates through all the numbers 5 times because the length of input array is 5. And after that, program finish and return the sorted input array. So that's how bubble sort works. And the time complexity of bubble sort should be order of n squares, because every time the program touches each number once. So with that being said, let's jump into the code. Okay, so let's write the code. First of all, create a bubble sort function. So bubble sort input. First of all, take the last index. So last index equal length of input -1, and start looping for underscore in range last index, and for I in range last index. And if input I is greater than input I plus 1, in that case, we swap the numbers. So I use temp variables equal input I, and input I equal input I plus 1, and the input I plus 1 equal temp. Yeah, actually that's it. And after that, just return input. So let's check. So print bubble sort and passing the like one. Yeah, something like that. And then, okay, let's execute. So 1, 2, 3, 4, 5, 6, 7, 25, 62. So looks good. Okay, from now on, let's try optimize the bubble sort. So first of all, let's check how many times this nested loop executed. So time equals 0, and then so we count up time here. So plus equal 1, and then so we should print time here, and then let's execute 64 times. So to reduce the execution times, okay, this underscore change it to, okay, let's say j, and then in the second loop, last index minus j, and let's check. Yeah, 36, and the input array is successfully sorted. 1, 2, 3, 4, 5, 6, 7, 25, 62. So why is that? Because in the first iteration, the biggest number moves the last index, in this case 62. So, and then we know that this 62 is a right position because that is our biggest number. And so we don't have to care about the last index from the second iteration. So we check the only this part. And then in the at the end of second iteration, we know that the second biggest number, which is 25, move to this index. So from the third iteration, we don't have to care about the last two index. We only care about this area. So to check the how bubble sort works, we should print here in input, and let's check how bubble sort works. Yeah, this is a first iteration. So 62 is the last index, so looks good. And actually 25 is also a right place. So right place 25 is a second place from the last. And then next 7 looks good. And next 6 looks good. And 5, 4, 3, 2, 1. So every time a new iteration start, so range of the iteration will be shrinked. So that's why so execution time is reduced successfully, like from 64 to 36. Okay, so let's clean up and optimize a little bit. So first of all, delete time, and delete print. After that, from line 8 to 10, so actually we can write like this: input I plus 1 equal, I copy this, I plus 1 and I. So this code is equal to these 3 lines. So I think this is a very Python way, but in Python we can do like this. So I delete this, and then let's execute the code. 1, 2, 3, 4, 5, 6, 7, 25, 62. Yeah, we can successfully sort it input array. Okay, so one more optimization. What if input array is already sorted? So in that case, let's count the execution time. Oops. So time equals 0, and update time here plus equal 1, and then before return we print time, and let's execute. So 36 is from first example, and 15 times is from second example. So even if input array is sorted, already sorted, we execute 15 times. So how can we improve the execution time? So in that case, we use flag. So let's say sorted equal true, and then every time we start a new iteration, first of all, we update sorted flag with false, and then if we execute like a swapping the numbers, in that case, update sort flag with true, and then after finish the nested loop, check the flag, and if not sorted, in that case, we should break the looping. So every time we update sort flag with false at first, and then if we don't swap any numbers, sorted flag still false. In that case, we know that input array is already sorted. So that's why we break here, and then just return input array. So let's check how many times. Yeah, yeah. In the first example, we can successfully reduce like once. And anyway, look at the second example. So we can successfully reduce the execution time from 15 to 5. So in that case, we can return the linear solution. We can return the input array with a linear solution, order of n. That's it. I hope this video helps you understand how bubble sort works, and I hope we can access LeetCode website soon. So if you have any question, please leave your comment below, and hit the like button, and please subscribe the channel. I'll see you in the next question.